So today we are going to talk about critical angle. But let's start by defining what is critical angle. A critical angle is the angle created when the refracted ray is aligned on the interface. So now let's show it by a diagram. Let's show it by a diagram. A diagram is like this. Let me say this one is a medium. And then after medium, then we have an interface. We have an interface, and then we have our normal. And then the light is moving from here to this point. So the angle becomes a critical angle when the refracted ray lies along the boundary or the interface. So now, what is the critical angle? The critical angle is the angle found between the incident and refracted, but it's when the refracted angle equal to 90 degrees. So we only have critical angle if refracted angle equal to 90 degrees. We only have critical angle only if the refracted angle equal to 90 degrees. This is the refracted angle, this is a critical. If this is 90 degrees, then we have a critical angle. But now, when we go forward for total internal reflection, now if the angle is greater than this, then it creates total internal reflection. But that's the topic that we are going to be talking about when we proceed. So now, the critical angle is only found only when the refracted angle equal to 90 degrees. And then also, the incident, the refractive index must be greater than refractive index of medium number 2. The light must travel from the medium of high refractive index to the medium of low refractive index. So when light travels from a medium of high refractive index to a low refractive index, therefore critical angle can be created. And then we have the formula for critical angle. The formula for critical angle is sine of theta critical equal to n2 over n1. So now we are saying this side is where the incident comes from. Then this becomes our n1, this becomes our n2. This is medium number 2, this is medium number 1. But remember, the light must travel from a medium with a high refractive index to a medium with low refractive index. If the light moves from a medium of low to high, therefore the critical angle will not be created. So now the formula for critical angle is refractive index of the second medium divided by refractive index of the first medium. That's where now we're going to find critical angle. Others, they can say critical angle equal to second function of n2 over n1. This is still the formula for critical angle. Either you write it this way or you write it this way, you'll still get to the same answers. So you can say shift sign of medium number 2 refractive index, medium over medium number 1, you'll get your angle of critical. So we only say critical angle is found when the refracted ray is on in 90 degrees. But remember, refracted ray must be along the interface or the medium. So this is the medium, this is the first medium, this is the second medium. So the refracted ray must align or be along the interface and then create an angle of 90, and then critical angle must be the one that has been created from there. So when we move to total internal reflection, now that's where now this bending of light does not go out, but it comes back into the same medium. That's why it's going to be called total internal reflection when we talk about other topics in geometrical optics. So in terms of critical angle, I believe that you also see what is going on here, and then you can be able to interpret it. But remember, the light must travel from a medium of high to a medium of low. For example, it can be water, which means it must go to air. It can be glass, in which it must go to water, and all those. So glass is higher than water, and then water is higher than air, the diamond, and all those. So these are the things in which you can look at and calculate.